In today's video, we're going to take a look at one of the more difficult concepts that we're going to see this year. And it's not difficult in the sense that it's hard to do. It's just a difficult concept to understand how we get the answer we do. It's a little bit of a different procedure. It's going to look kind of a little strange. I'm going to show you hopefully the math that's behind it and why we do what we do. And then once you figure that out, once you see how to do it, it's very, very simple. Like I told you guys before in a past video, if you can multiply fractions, you can divide fractions. And that's essentially what we're going to be doing today is multiplying. But the idea on how that comes about is what makes this kind of one of the more confusing concepts we'll do this year. I do have one vocabulary term for you today, and that vocabulary term is reciprocal. And a reciprocal definition is two numbers, and in this case we're talking about fractions, whose product is 1. Remember, product is the answer to a multiplication problem. So it's two numbers, or in our case, like today, fractions, that when we multiply them together, give me the whole number answer of 1. Now, we're not going to address this right away. We're going to kind of come back to this idea later on. So keep this vocabulary term and this definition in your mind as we work through here, and we'll come back and see how this applies to what we're doing today. So I'm going to try to attempt to show you the math behind why we do what we do for this. So let's just take 4, for example, the whole number 4. Let's draw a model of the whole number 4. So we're going to draw 4 circles here. It could be pizzas, pies, whatever you want to call it. All right. So let's pretend I have 4 pizzas, and we'll go ahead and color them in because we always have a colored in to represent one whole. Let's pretend I have 4 pizzas, okay? And I'm having a pizza party. And I'm going to give every student that I have 1/4, okay? So I'm going to take and divide my 4 pizzas up into fourths. So hopefully we're going to model what 4 divided by 1/4 looks like. Okay. So in order to do this, for me to give 1/4 of a piece of pizza to a student, I'm going to have to cut my pizzas up. So I'm going to have to cut them up into fourths. So here we go. There's another one. Here's another one. And the last one we've got cut into fourths. So now my pizzas are cut into fourths. I still have 4 whole pizzas. They're just cut into fourths. Okay. So what I'm going to do is I'm going to go ahead and give 1/4 of a pizza to all the students that are in my room. We're going to figure out how many students that would be, how many students I could feed with 1/4 of a pizza. All right, so this goes to student A, this one to B, C, D, this student E, F, G, H, I, J, K, L, M, N, O, P. All right, so we'll just pretend that that's the first name of each student. So I've given 1/4 of the pizzas to every student that I have. How many students did I give pizza to? So we're really saying 4 divided up into fourths gives me how many pieces of fourths or whatever. So the answer to that, if we look and we do our counting, that's A, B, C, D, there's 4. E, F, G, H, there's 8. I, J, K, L, that's 12. And M, N, O, P, that gives us 16. So I had 16 fourths here. There are 16 fourth pieces of pizza. So if I had 4 pieces of pizza and I cut them into fourths and I gave a fourth out to each student, how many students could I feed? I could feed 16 kids. But this kind of goes against what we've done in division in the past. In the past, when you take a number like 10 and divide it by another number, let's say 2, you get the answer of 5. 10 divided by 2 is 5. The answer is smaller than what we started with. It works for like 20. 20 divided by 4 is 5. 5 is less than 20. But here, we start with the number 4, and we end with 16. Now, if you're looking at the problem, how could I take 4 divided by this fraction that's here and end up with a whole number of 16? The division really doesn't work out that way. But notice the number got bigger. You might see a connection between these two fractions. And you might see the connection that 4 times 4 equals 16. Okay? But notice this says division. Okay? This is a division problem. Now, it's really difficult for us to work this problem as is. But we can look at this a different way. I can take 4 and make this into a multiplication problem. And here's where the reciprocal idea comes into play. Remember, a reciprocal is two fractions multiplied together that equal one whole. So let's just take our 1/4 for a second. What would I need to multiply 1/4 by to get a number over another number, which we all know in order to equal one whole has to be the same as the numerator, same as denominator. In this case, if I take the numbers 4 over 1, 1 times 4 is 4, 4 times 1 is 4, and 4/4 is equal to 1. Now think of it this way. When I did those math problems earlier, I said 10 divided by 2. 10 divided by 2 is 5, right? Or I can also look at it the opposite way. 5 times 2 is 10. So we can sort of work our problems a little bit differently with multiplication and division. So I'm going to work my problem a little bit differently here. Instead of dividing by 1/4, I'm going to multiply by the reciprocal of 1/4, which is 4 over 1. So let's take a look what happens now if I change this math problem to 4 times 4 over 1. The first thing I have to do is make my 4 into a fraction, which would be 4 over 1. 4 times 4 is 16. 1 times 1 is 1. And now I have 16 over 1, which is the whole number 16. So I come up with the correct answer. Now, like I said, this is kind of one of the more confusing and difficult to comprehend concepts that we'll deal with this year. It's a very, very simple process. We're going to use the reciprocal of the fraction and actually multiply instead of divide. It makes the problem much, much, much easier to do. I don't want to have to draw a model out for all these problems. So let's try another one and see if we can make some connections about this whole reciprocal idea. Let's try another example. Let's look at, let's do something with thirds this time. Boxes are easier to draw thirds with, so I'm just going to make 3 boxes. I'm going to have 3, and I'm going to divide it by 2/3, meaning I'm going to take 3 boxes, and I'm going to give 2/3 of it to, I'm going to give 2/3 of it away. It doesn't really matter how I do it, it just matters that I do it. So let's go with 2/3 here. I'll shade in my boxes, and while I'm doing this, think back to what I talked about the reciprocal, and what it looked like with the reciprocal, and how those two numbers sort of corresponded. Remember, we could see within the problem there was sort of a multiplication we could do. Let's see if this works this way. All right, if I'm going to divide these 3 up into 2/3, I first have to cut it into thirds. Okay. And so my first person gets this one. Here's 1. My next person gets these 2/3. My third person gets these 2/3. This will be the fourth person. They're going to get this third connected to this third as well. Okay. But that leaves me with 1/3 left over. So let's look here for a second. Right now my answer sits at 4. But I have to be careful. How many pieces did I give away? I was giving 2/3 to each person, right? How much is left over right here? 1. Now, yes, it's 1/3, but how much was each person getting? They were getting 2. What's half of 2? 1. So technically the answer is 4 1/2. Again, kind of a difficult concept when we start looking at it this way, but let's think about it using a reciprocal. Let's rewrite our problem here, but use a reciprocal and multiplication this time. We have 3. Let's make that a fraction, 3 over 1. Let's change our problem to multiplication. And instead of doing 2 over 3, let's do the reciprocal. 2 over 3 times something should give me the same number over the same number. So what would I do? Flip those numbers over. 2 times 3 is 6. 3 times 2 is 6. And if we have 6 over 6, that equals 1. So I'm going to use 3 over 2 in this case. All right? 3 times 3 is 9. 1 times 2 is 2. Improper fraction, I need to do the division. 9 divided by 2. 2 goes into 9 4 times. 2 times 4 is 8. I do my subtraction. 9 minus 8 is 1. Let's do our backwards check mark to get what our answer should be. 4 1/2. And right there, we have the exact same answer as up here. Now, one thing I want you to take a look at right now and understand about the whole concept of a reciprocal. Look at these two numbers, 2/3, 3/2. Look back at the previous problem. 1/4 and 4/1. What do you notice about those two fractions? All I'm doing is flipping the fraction upside down. So 1 goes to the bottom, 4 goes to the top. In this one, 2 goes to the bottom, 3 goes to the top. All you got to do is flip the fraction over, and you have the reciprocal, and you can multiply. So that's how we're going to do this. It applies in all situations, even if I have two fractions. If I have two fractions such as 2/5 divided by, let's go with 1/3. Okay. If I'm going to do this, it's pretty simple. We leave the first fraction the same. Always leave the first fraction the same. Never, ever do a reciprocal on the first. It will give you the wrong answer. It gets you a different number to start with, and starting with a different number is going to give you a different answer. Leave that one alone. We're going to change division. That's not going to be division anymore. We're going to change that to multiplication. And we've got 1/3. Okay? 1/3 is equal to something times 1/3 times another fraction equals something over something, which is the whole number 1. How can I make the same numbers on top and bottom? Flip my fraction upside down. 1 becomes the denominator, 3 becomes the numerator. 1 times 3 is 3, 3 times 1 is 3. 3/3 is equal to 1. So my new fraction looks like 3/1. At this point, if you're doing this and you come across some numbers that you can actually simplify with our cross products like we have before, diagonal from each other, go for it. Now would be the time to do it. It'll make your life easier, okay? But we can't in this problem, so let's just do it as is. 2 times 3 is 6. 5 times 1 is 5. I've got an improper fraction. So I'm going to take 6 divided by 5. 5 goes into 6 once. I do my subtraction. My answer, 1 1/5. Okay, pretty simple. All right, I want you to try one now. The first one I'm going to give you is going to be a whole number divided by a fraction. So let's take the whole number 5, okay, and let's divide that by, let's try 3/4, okay? So go ahead. Remember the steps. Leave the first one the same, change to multiplication, flip the second fraction. Hit pause, give it a shot, work your answer, and when you're ready, hit play and see how you did. Okay, the first step you had to do was to write 5 as a fraction, which is 5/1. All right, next thing we're changing division to multiplication, and we're going to do the reciprocal for 3/4. The reciprocal is the number that would multiply by 3/4 to get us the whole number 1. So we flip it. Top number goes there, bottom number there. 3 times 4 is 12. 4 times 3 is 12. That's my reciprocal. So I'm going to multiply now by 4/3. Can we simplify in this case? No, we can't. So let's move on. 5 times 4 is 20. 1 times 3 is 3. I have to do my division now. So I have to take 20 divided by 3. All right. 3 will go into 20 6 times. 6 times 3 is 18. Do my subtraction. 6 2/3. Simplest form? Yes. We're good to go. All right. Check to make sure. Did you start with the correct problem? Did you make sure you flipped it? That's where a lot of the error lies, is when we don't remember to flip that second fraction. All right, let's try another one. This one's going to be 2 separate fractions. Okay, so let's do 4/9 divided by 2/3. Go ahead, hit pause, give it a shot, and push play when you're ready to see the results. All right, so let's follow the procedures again. First thing we're going to do, we're going to leave this fraction the same, change division to multiplication, and the last thing we're going to do is we're going to flip the second fraction. We're going to do the reciprocal. So 2 times or 2/3 times a number, it's equal to, oops, I'm making too many blanks there. That last one should say 1 whole. So 3 over 2. 2 times 3 is 6. 3 times 2 is 6. 6 over 6 equals 1. So my new fraction then flipped will be 3 over 2. Again, let's stop right here and say, can we simplify? And in this case, yes, we can. We can divide the 3 and the 9 by 3. 3 divided by 3 is 1. 9 divided by 3 is 3. And we can do the math. You cannot simplify at the very beginning. Because remember, you have to flip the fractions so they would no longer be cross products from each other. So that would not work. You can only simplify once you have done the reciprocal. Okay, we can do this. 4 times 1 is 4. 3 times 2 is 6. Simplest form? No, not quite. You can divide 4 and 6 by the same number, which is 2. 4 divided by 2 is 2. 6 divided by 2 is 3. And my answer then is 2/3. Okay. Again, double check. Make sure you started with this problem right there. Also, make sure you simplify too. You still have to have answers in simplest form. Now, normally I only have you do 2, but today I'm going to have you do a third one. Okay. And the third one's I'm going to do it a little bit differently. This is kind of a challenge here to you. So instead of doing a whole number divided by a fraction, I'm going to take a fraction. Like let's take 4/7, and we're going to divide that by the whole number 8. Okay? So that's what we're starting with. Give this one a shot. This is a challenge. So if you struggle with this one, that's okay. I'm challenging you in this case. Hit pause, give it a shot, and we'll see how you do. Okay, the key is setting this problem up correctly. We always leave the first fraction as is. Okay? We always change division to multiplication. And then we always have to do the reciprocal of our whole number. Now, here's where a lot of students make mistakes. I see a whole number, and I have to write the whole number as a fraction, which is 8 over 1. And then we can go ahead and multiply. Not so fast. That's where the mistake comes in. Because 8 over 1 is the fraction form of the whole number 8. We still have to write a reciprocal. So the fraction that goes with 8 over 1 to give us the whole number 1 is 1 over 8. We still have to make sure that we flip this fraction. So 8 over 1 is not what we want to multiply by. We want to multiply by 1 over 8. You still have to make sure you flip that fraction and find its reciprocal like we did over here. You can simplify in this one before you start. 4 divided by 4 is 1, and 8 divided by 4 is 2. 1 times 1 is 1. 7 times 2 is 14. 1 on top tells me we're in simplest form. Again, I say this is one of the more difficult concepts to understand. One of the more difficult concepts we're going to do this year, just because of the math behind it. But if you remember the simple procedures of leave the first fraction alone, change it to multiplication, and flip that second fraction, give it a reciprocal, that flipped over fraction, and do your multiplication, you're going to be just fine. As always, if you're having trouble, questions, problems, come in and see me either before school, during lunch, or after school. Thanks, guys.